Right, we're on our last page of notes. So we're going to talk about some definitions, and then we're going to talk about, one of them will have a formula, but we're not going to spend a lot of time with these problems. You may see it on the test, but we're not going to do a separate quiz or separate practice or anything. So we're talking about the difference between effusion and diffusion. Diffusion is the movement or gradual mixing of two gases just due to their spontaneous random motion, the regular motion that they would have. It occurs pretty rapidly in gases because the particles are moving so fast. So example of that would be smelling a perfume. You know that if somebody sprays perfume, even if it may not be right next to you, you're going to get that smell eventually. Air freshener is another example of that. Effusion may not be that word that you're as familiar with. It's the movement of gas particles through a tight opening in a container. So if a gas is contained in a container, then it's going to be causing pressure against the surface of that container. And if there's a little hole, then it's going to would move through that hole, and that's called effusion. So flat tire, and also helium effusing from a balloon. We all know if we get a balloon blown up, give it a couple of weeks and it'll lose that air, and it won't, if it's had helium in it, and it won't be floating any longer. That's because that helium gas has effused out. Rates of diffusion and effusion depend on the velocity of the gas particles, and velocity depends upon the mass of the particles. So that relationship comes into what's called Graham's law. And Graham's law says the rate of effusion of gases when it's at the same temperature and pressure are inversely proportional to the square roots of the molar masses. So what that is saying is if I increase the molar mass, I'm going to decrease the rate of effusion. The heavier the gas, the slower it would move, so that rate would decrease. And that's represented by the formula, which is rate of A over rate of B. So this is done like if you're doing a comparison between a couple of gases. So this one would be seeing how much faster gas A is going to infuse than gas B. And that is the square root of the molar mass of B divided by the molar mass of A. So if we look at two different gases, ammonia, which is NH3, it has a molar mass of 17.04 grams per mole. And then hydrochloric acid, it can be a gas, and it has a molar mass of 36.46 grams per mole. So ammonia is lighter, so we know it's going to effuse faster, but we're trying to find out how much faster it does, and you can use that equation for that. So ammonia is the one that I'm interested in, so I'm looking at the rate of ammonia compared to the rate of hydrochloric acid. And that's the square root of hydrochloric acid, which is 36.46 divided by A, because what goes under the square root is the inverse or the flip. So that would be 17.04. So you take your 36.46 divided by 17.04 and then take the square root of that. Sig Figs are kind of a little difficult. If you had this on a problem, I'd have to tell you how many Sig Figs, like I did on number 4 today, because you don't have a beginning amount. So we'll say we're going to go 2 places behind the decimal. So 1.46. So that's telling you that ammonia fuses 1.46 times faster than hydrochloric acid. And once again, that has to do with the fact that the NH3 is going to be lighter, has a smaller molar mass. All right, just real quick on that. We're not going to worry about that other problem. So that gives y'all some time. You can work either on your review for tomorrow, or you can work on your stoichiometry practice, or if you have any questions on your quiz, you're welcome to ask those too. But you got about, I don't know what we got, about 15 minutes, I think, for y'all to work on your stuff.